The following is brought to you by FMC. Learn more by visiting ag.fmc.com.
Okay, let's get talking about biologicals. Joining us right now is Erin Burton. She is the technical sales manager with FMC. How are we doing today, Erin?
Very good. Thank you. Thanks for having me back.
Yeah, you're having a great fall?
Very good.
Good,
Beautiful.
good. And I'm maybe going to see a Jagger trade later this week as well, which is great. So, okay, let's talk about biologicals. And right now we're seeing more biological products come onto the market that combine several different organisms into one formula. And this is kind of a shift, I think, out in the marketplace. Why is that becoming more common, and why are companies doing it? Like, what's the benefit?
Well, I think we can think of it as productivity really comes down to two things. So nutrient acquisition. And historically, when we think of that, it's our fertilizers, our rhizobial inoculants. But now we're starting to add a whole dimension here with bionutrition, with adding microbes together in order to solubilize that phosphorus, increase nutrient uptake. And then the other thing is stress resistance. So that's your biotic and your abiotic stresses. So biotic, we have our fungicides, we have our seed genetics, and then we can add the biocontrol in there where we're adding multiple microbes in order to help with suppressing that disease and just with resistance, so able to keep our chemistries longer. And then when you think about abiotic stresses, that's your environmental, and we don't have a lot in that space, really. I tried to come up with some good examples, and they all came around water. So tile drainage, irrigation. But now we've really started to study things like biostimulants that are able to help with those environmental stresses and work with the plant and the hormones and how the plant reacts to those stresses. And then there's communication molecules out there now helping with those abiotic stresses. And when we think about it, I mean, these microbes and plants, they've co-evolved for millions and millions of years. So they've come up with strategies to work together, and a lot of synergies. The classic one is rhizobia and a legume plant, so that end fixation. But then there's synergies between microbes. So you start adding different microbes together, and we start to really see an additional benefit. So companies have realized that, science has realized that. So we're starting to put them together in order to get the most of that plant. And then communication. So the plant, again, talking with the bugs in the soil. We see it if there's a stress, then the plant will send out like signals saying, I need help, and microbes can come into play and help with that.
It's kind of like from a chemist, from if you compare it to the chemistry side, it's like multiple modes of action.
Mm-hmm.
Same idea,
Very
right?
good way to put it. Yeah. Yeah.
Yeah. Okay. So talk about some of the combinations that we should know about that benefit growers.
Well, one that's been around for quite a while is rhizobia and a P-solubilizer. So we know with the end fixation process, it takes a lot of phosphorus. So if you combine a phosphorus-solubilizer with an end fixer, a rhizobia, yields really increase. We do have some data to show in the graph where a pea lentil there with just a single action, so just rhizobia alone, is our 100% control. Then we add a phosphorus-solubilizer in there, and all of a sudden we have 8% more yield. And that's across 115 trials. So that's a fairly large data set. So we know there's a really good synergy when you add that phosphorus-solubilizer with the end fixer. And the same goes with chickpea data and the soybean data. We're really seeing large yield increases when we put them together. That whole process, it requires a lot of phosphorus within that nodule for it to happen. And then with that, like another combination that we have out there is Bacillus amyliquafaciens and Trichoderma virens. So these two together really help the root system. So you're getting bigger roots underground, which means more nutrient acquisition, better exploration of the soil for water uptake. And these, we also know, work really good on high organic soils. They're breaking those bonds in high organic soils so more nutrients go into the plant. So we have those two. And then if we layer in a phosphorus-solubilizer, which is also helps with the root system and whatnot, we're getting this really robust plant. We're getting more phosphorus in the soil. And we know that one works on lower organic matter soil. Then all of a sudden we're covering this whole range of environmental conditions. And the same will go if you're adding even two strains of the same bugs together. So one may work really good in warm soils, one good in cold soils, and then two strains of a Brady. So one might work good in one and another in another soil. So they're kind of covering off that entire range of conditions. So by adding them together, it's you're getting the most out of your products.
And there had to be some testing in terms of not only how, like, is there with, two organisms put together or three, and what, the impact that that has on the crop and the soil, but also to make sure that, putting two things together don't like neutralize each other as well and make one ineffective like that. So there's
Right.
a lot of research
Antagonistic
Sorry.
is what we say, that they're
Yeah.
not antagonistic to one another. Yeah. Yeah, for sure.
Very cool. Okay, so there's the combination of microorganisms, but there's also this I've heard about this idea of signaling molecules. Do I have that correct? And if so, what does that mean?
So we have what is called LCO signaling molecules. So what that is the plants are talking to the rhizobia is talking back to the plants. And so essentially when a seedling starts out its life, it grows and it becomes in a really nice position. It will send out its own signaling molecule, which is a flavonoid, out into the soil saying, I'm here, I'm ready for end fixation, I'm ready for colonization. The rhizobia is very specific to that plant. So it will recognize that flavonoid and recognize if it's the right rhizobia, and it will send its own signaling molecule back. And that's what an LCO is. That's the signaling molecule from the plant, or sorry, from the rhizobia back to the plant. And then the plant then starts the whole process of changing its genes, changing its root structure so that the rhizobia can enter and form that nodule. So the rhizobia is talking back to the plant. And it's not just rhizobia, it's also mycorrhizae as well, has an LCO molecule that they send back. And then the plant starts the gene expression as well. So pretty neat.
I need to dumb this down because I really did not do well in biology in high school. How do we know all this?
Yeah, like this technology has actually been around for 20 years.
Okay.
Discovered in Ontario. Yeah, a lot of studies behind it. You can really do deep dives into the literature to find out about it. It's pretty neat.
Yeah, this idea of in that canopy, the plant, this interaction is just it is so cool and so fascinating. You just try to figure out, okay, how do I leverage it as the grower to benefit myself, right? And obviously have more productivity on those acres. So let's talk about that, how this all comes back to the grower. How does it
Right.
help the grower? What's the benefit? Let's talk about those.
Right. And we can take it right back to the nutrient acquisition and the stress resistance. We're getting more nutrients up into our plant with these microbes. We're helping with abiotic stresses, just basically helping that plant through its entire lifespan to overcome some of these issues that it may face. And we know every year they're facing issues nonstop throughout the growing season. So it's it's a way for the plant to get the most potential out of it in terms of yield.
Okay, awesome. This whole biological space is one where we're continuing to learn and we're continuing to see innovation and new products brought to market. And I'm just so fascinated where we're going to be in like 5 or 10 years with this product category.
Yeah, and the science is just it's ever expanding, and they're now looking underground more than they ever have before. So it is a pretty exciting realm to be in at the moment.
Yeah, which the underground component though is what makes it a little bit makes it difficult because it's non-visual, right? Like
Mhm.
when we look at, weed control, uh, seaweed, spray weed, kill weed, when we're talking about under the soil profile, we're not necessarily seeing those visual. We need to that's We're not seeing the visual impacts. Obviously, root size is one we can pull later and look at that and things like
Right.
that. But ultimately, it comes back to what were the results from maybe tissue testing or obviously ultimately yield, right?
Right. And then we're always trying to look at the data, look at what was happening environmentally at that time to try and make that correlation. Okay, it was drought during this specific
Right.
growth stage, or it was too wet at this specific growth stage. So trying to make those connections in order to get consistent products, because the grower wants consistency. They want to see that every year this is going to have an effect, and every year environmental conditions change. So we're continually looking at the science to make it consistent.
Yeah, Aaron, and I know you've been really focused in this biological space. You just I kind of when you as you were talking about like some of the different conditions and the variables, a lot of times when I talk to companies about fungicides, we've moved from like, okay, it's not a reactive decision, it needs to be more proactive. Is the biological decision, is that similar, or do we wait to see the stress or be sure of, have we feel comfortable with the probability of the stress based on the conditions and then we act? Or I guess we're not afforded that all the time, especially when we're talking seed application.
Right. And we have to remember these are microbes, so they need time to multiply in the soil. They need time to grow and metabolize and all those things that need to happen in order for us to see that yield response. So it's not so much reactive, it's more proactive, more like an insurance for a
Yeah.
lot of things.
Okay, cool. That's I appreciate that comparison. Okay, we're almost out of time here, Aaron. So I know that FMC does have some resources when it comes to biologicals. Let's get that in.
Right. You can go to the website at fmc.ca and look at tons of field results and what products, and a lot of technical reviews are on there too for good resources.
Great stuff. We've been talking to Erin Burton. She's technical sales manager for FMC. Erin, thanks a lot for joining us here today. Appreciate it.
Thank you.